project was to try and predict the number of wins in an MLB team based off just pitching statistics alone. So overall, this project examines how pitching performance contributes to the overall team wins in Major League Baseball using the layman data set, which is created by a man named Sean, and he is his data set dates back to 1871, which is kind of crazy, but which has way too much. So we decided to go down. I decided to go down to 1980 for these predictors for this data set, and then based on the rules and regulation changes, and we'll be removing the years 1981, 1994, and 1995, as well as 2020, because they did not play a regular 162 game season. I chose to predict or try and predict the amount of wins for a baseball team because many people have tried before, and it's well known in the sports industry to try and predict who's going to be good, who's going to be bad, and so give it a shot. So some of the variables that we'll be going over are the amount of wins, ERA, which is earned run average, which is the total number of runs that scored against a pitcher that's not due to errors or cast balls. For example, if a pitcher gave up 3 runs in 1 inning, their ERA would be 27 because there's 9 innings in a baseball game. Hits allowed, walks allowed, strikeouts on pitchers, home runs allowed, opponents' runs allowed, shutouts by pitchers, and the saves. So here's a little bit of the relation for each variable. So most of these variables are correlated with each other, so we'll have to watch out for multicollinearity. Going to the exploratory data analysis, I went through each variable individually to see and looked at their histogram to see their distributions. Each variable is somewhat normal to skew, with only a couple outliers and runs allowed and home runs allowed. But overall, they're mostly linear or normal. When looking at the correlation matrix between each variable, we see that runs allowed and ERA are very, very related to each other, and so we'll have to keep an eye out for multicollinearity between those two variables, as they affect a lot of the other variables in this data set. So going into our model, we are using a multivariable regression model because wins are influenced by many different predictors rather than just a single metric. So using this type of model, we'll be able to predict each predictor while controlling all the other predictors. And then using the best subsets, we'll be able to compare each possible model and be able to choose the best one for us based on the highest adjusted R-square as well as the significance of each predictor. Going through each, we're going to go through each assumption. For each, so we'll go through our linear, normality, equal variance, influential points, and multicollinearity to see how well this model that the best subsets chose for us does. Going through each one, they seem very normal. There are no issues with linear. There's equal variance. There's normality, as well as there's no influential points in this data set. But there is multicollinearity between runs allowed and ERA, which raises some concerns for this model. And because of this, I decided to remove runs allowed from this model, as well as you see that I stated before that there are 8 variables that we'll be going through, and there's only 6 in this model. There were 2 that were significant, that being walks allowed as well as strikeouts allowed. So they were removed from this model, and which left 6 predictors that were significant. But because runs allowed had a high VIF, I decided to remove that as well. But you also see that ERA also had a high VIF, and I decided to keep ERA in because it is a very well-known predictor to predict the amount of wins for baseball, as well as an important pitching statistic. And with the hope that I removed runs allowed, the VIF of ERA would go down. So that brings me to my second model, which used 5 predictors instead of the 8, which all the assumptions were very similar. And going to multi-collinearity, it went down to 7. Even though this is still a very high number, it is below 10, which means we can still consider it, but just keep an eye on it to make sure that there are no issues on the road. With this model, each predictor was significant, and it had a adjusted R squared of 55. So brings me to my results. So this final model predicts the number of wins in baseball season using ERA, walks allowed, home runs allowed, shutouts by pitchers, and saved with the adjusted value of adjusted R squared value of 0.5573, showing that there is a 55% variability explained by these predictors, and with after accounting for model complexity. If you look in this model, you notice that home runs allowed and hits allowed are positive factors for this model. You'd think allowing more runs and allowing more home runs would decrease the amount of wins, but for some reason it increases. When we look at these 2 scatter plots between hits allowed and home runs allowed, you see a negative correlation between wins and hits allowed and home runs allowed, which is really interesting. But you can see in the values, they're extremely low. So say a team wins 100 games, the hits allowed only increases the amount of wins by 1 game, while the home runs allowed increases by 7, which when looking at the big picture is not that big of a deal, but if you're fighting for a playoff chance or trying to make it more accurate, that's not the best thing. But if these variables would be removed, that would be variable bias. So I decided to keep them in. Some limitations of this study, there is a moderate adjusted R squared value. It only accounts for 55% of the variability, rather than what we hope for is 100 for everything. But so we have to keep that into account. And there'd be more pitching statistics that could interact with, and the data set is only up to 1980. So there could be a shift in pitching effectability over the years. And then there are many other factors that could impact winning games, like batting or fielding, that might influence the amount of wins more. So in conclusion, this regression model explains how pitching performance of the MLB teams from 1980 to present relates to the amount of wins a team has in the regular season. So hits allowed, home runs against, shutouts, saves, and earned run average are all significant predictors of the model, showing that run retention is an important outcome of winning games. So the reason I chose this was I will be doing, I got the lucky opportunity